channel Knowledge How. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your physics class 11 part 1. This is your class 16 where we had done your unit 1 in the last classes, which is your physical world, and today we'll start continuing with unit 2, which is units and measurement that we had started in the last classes as well. So here we'll start discussing about it, but we had done your 15th questions in the last classes. Today we'll start continuing with the questions only, that is in the 16th question of the sessions. And as I told you, the question is that SI unit of energy is J equals to kg m square second inverse square. That of speed v is m seconds inverse, and the accelerations of a is m second square inverse. And which of the formula for the kinetic energy K given below that can you rule out in the terms that is basic on the dimensions argument, where m stands for the mass of the body. The options were K equals to m square v cube, and K equals to half mv square, K equals to ma, K equals to 3 by 16 mv square, K equals to 1 by 2 mv square plus ma. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once. You can also enjoy the video as well. So start with this. SI unit of energy kg square second inverse square. That of speed v is m second inverse, and of acceleration a is m second inverse square. Which of the formula for kinetic energy K given below can you rule out the basis of dimension null arguments? M stands for the mass of the body. So the options we talk about it. The option 1 we have K equals to m square v cube. B option is K equals to half mv square. C option is K equals to ma. D option is K equals to 3 by 16 mv square, and the E option is K equals to half mv square equals plus ma. So with the same we go for it, and here as you can see here in the same way that every correct formula or equation must have the same dimensions on the both sides of the equation, and also only quantities with the same physical dimension that can be added or subtracted. The dimensions of the quantity the right side are, which is your m square l square t cube and t inverse cube, and this will be the right side you have to So I just write it down so that you will be able to know. So right side में क्या होना चाहिए dimension? It will be m square l cube t inverse cube. Okay. So for the first one, if I'm talking about for m square v cube, if we have your dimension is m l square t inverse square. So is that right? And for B, A and D, this is only A के लिए, B के लिए and D के लिए, यही है. So is that right? ML inverse T square for C, and the quantity on the right side for E has no proper dimension. So since the quantities of the different dimensions have been added, since the kinetic energy has the dimensions of ML square T square, formulas for A, C, E are ruled out, so that the dimension argument cannot tell which of the two, B or D, is the correct formula. So for this, one must turn to the actual definitions of kinetic energy that will discuss in the chapter 6, that will discuss further. So the correct formula for kinetic energy is being given by B. So here will be B. That will be the right answer for this question. Now we'll talk about for the next the next proper discussion about the topic will be the another, and that is your deducing relation among the physical quantities. So deducing relation among the physical quantities. That we have. So on the same way we talk about it, that we will discuss here. So here we go. Here in the method of dimensions, that can sometimes be used to deduce the relation among the physical quantities, and for this we should know that the dependence of the physical quantity on the other quantity up to the three physical quantities or linearly independent variables, and considered it as a product type of the dependence. Let us take an example as well. So we'll go for the questions and then we'll deal with the questions here in the detail about it. The question we have, you have to consider the simple pendulum having a bob attached to the steering string and that oscillate under the actions of the force of gravity. Suppose that the period of oscillations of the simple pendulum depends on its length, which is L, mass of the bob is M, and the acceleration due to the gravity is G. You have to derive the expressions for its time period using the method of dimensions. So we go for the same here. So here we go. That is the 17th question. So consider a simple pendulum having a bob attached to a string that oscillates under the action of the force of gravity. Suppose that the period of oscillation of the simple pendulum depends on its length L, mass of the bob M, and acceleration due to gravity G. G. Acceleration due to gravity is G. Derive the expression for its time period. For its time period. Using method of dimensions. That we have. So here we go for the same, where the dependence of the time period t on the quantities L, G and M as a product that may be written as here. So here we go, and that was what we'll have to talk about it. T equals to K Lx G Y and mz. So where K is dimensionless, and that is dimensionless constant, and x, y, z are the exponents. By considering the dimensions on the both side, we have m0 m0 t1 equals to L1 t my inverse square by m1 z, which is Lx plus y t inverse 2y and mz. On equating the dimensions on the both side, we have x plus y equals to 0 minus 2y equals to 1 and z equals to 0. So that then t equals to k L and G. Now we go further to solve this. We'll be having t equals to k under root L by G. You have to note that the value of the constant k that cannot be obtained by the method of dimensions. Here it does not matter if some numbers multiplies the right side of this formula, and because that does not affect its dimensions, and actually k equals to 2 pi, so that t equals to 2 pi under root L by G. So here in the same way, this dimension analysis is very useful in deducting the relation among the interdependent physical quantity, and how the dimensionless constant in the physical quantities, and the dimension constant cannot be obtained by this method. The method of the dimensions that can only test the dimensions validity but not the exact relationship between the physical quantities in any equation. It does not distinguish between the physical quantities having the same dimensions. A number of exercises at the end of this chapter will be helpful for to develop the skills of the dimension analysis that we'll discuss as well. So here that what we had learned about this chapter is your physics is a quantitative science that is based on the measurement of physical quantities, where the certain physical quantities have been chosen as fundamentals of the base quantities such as your length, mass, time, electric current, thermodynamic temperature, amount of substance, and the luminous intensity, where each base quantities is defined in the term of the certain basic arbitrary chosen but properly standardized reference standard called units such as meter, kilometer, kilogram, second, ampere, Kelvin, mole, and candela, where the units for the fundamental or the base quantities are called the fundamental or the base units. Other physical quantities that is derived from the base units that cannot be expressed as the combinations of the base units and are called derived units. A complete set of units for the fourth fundamental and the derived is called the systems of unit here. The international systems of unit, which is a SI unit based on the 7 base units, is has been representing here. Present internationally accepted unit systems and is widely used throughout the world. The SI unit are used in all the physical measurements of both the basic quantities and the derived quantities obtained from them, and certain derived quantities are expressed by means of SI units and a special name such as joule, Newton, watt, etc. The SI unit have a well-defined and internationally accepted unit symbols such as M for meter, kg for kilogram, and S for second, A for ampere, N for Newton, etc. Physical measurements are usually expressed for the small and the large quantities in a scientific notation with power of 10. Scientific notation of the prefix are used to simplify the measurement notations and numerical computation, giving indications of the precisions of the numbers as well, where the certain general rules of the guidelines that must be followed for using the notation for physical quantities and standard symbols for SI units. Some other units is SI prefixes for the expressing the properly the physical quantities and the measurements here, where in computing any of in terms of any computing in any indirect physical quantities, the units and derived quantities involved in the relationships are treated as though they were algebraic quantities till the desired units are obtained, where direct and indirect method that can be used for the measurements of physical quantities in measured quantities while expressing the result of the accuracy and the precision measuring the instrument along with the errors in the measurement should be taken into the account. In measured and computed quantities, the proper significant figures only should be retained. The rules of the determining the numbers of significant figures that carrying out the arithmetic operations with them and rounding off the uncertain digits must be followed, where the dimensions of the base quantities and the combinations of these dimensions describes the natures of physical quantities. Dimensions analysis that can be used to check the dimension consistency of equation, deducing the relation among the physical quantities, etc. And a dimensionally consistent equation need not be actually an exact correct equation, but a dimensionally wrong and inconsistent equation must be wrong here. Now coming towards some of the related to the questions that we have to discuss as well. So yes, there will be questions where you have to answer it out in the fill in the blanks manner. We just tell you the volume of the cube side 1 centimeter is equals to the dash meters cube. The surface area of the solid cylinder of the radius 2.0 centimeter and a height 10.0 centimeter is equals to the dash mm square. A vehicle moving with a speed of 18 kilometer hour inwards covers dash meter in 1 second, that you have to answer. Another is the relative density of the lead is 11.3. Its density is dash gram centimeter inverse cube or kg meter inverse cube. You have to answer it out. Now another question we have here for the fill in the blank for the suitable conversions of the unit as well. In the same way, 1 kg m square second inverse square equals to grams centimeter square second inverse square. 1 meter equals to dash y 3.0 meter second inverse square equals to kilometer inverse hours here. G equals to 6.67 into 10 to the power minus 11 Newton meter square kg inverse square, which is equals to centimeters cube second inverse square gram inverse square. That is will be here. The another important question we'll talk about it, which is being a calorie is a unit of heat or energy, and it's equals about 4.2 joule, where 1 joule equals to 1 gram meter square second inverse square. Suppose we employ a system of units in which the unit of the mass equals to a kg, the unit of length equals beta alpha kg and beta meter. The unit of the time is gamma second. Show that the calorie that have magnitude 4.2 alpha inverse beta inverse and gamma square in the terms of the new unit you have to explain. The another question we have here for the same is to explain the statement clearly. To call the dimensional quantity large or small meaningless that without specifying a standard for comparison in view of this, reframe the following statements wherever necessary. The first we have your atoms are very small objects. A jet plane moves with a great speed. The mass of the Jupiter is very large. The air inside the room contained a large number of molecules. A proton is much more massive than an electron, and the speed of the sound is much smaller than the speed of light. Now we have another question here as well. That is, a new unit of the length is chosen such that the speed of the light in the vacuum is unity. What is the distance between the sun and the earth in terms of the new unit of the light? And it takes 8 minutes and 20 seconds to cover the distance. The another question, important question, is which of the following is the most precise device for the measuring length? Where are Arundel calipers with 20 divisions of the sliding scale. The another is the screw gauge of pitch 1 mm to and 100 divisions of the circular scale. The next is the optical instrument that can measure the length to within a wavelength of light. The another is the student measures that the thickness of the human hair by looking at through a microscope of magnification 100. He makes 20 observations and find the averages estimate width of the air and field of the view and microscope into 3.5 mm. What is the estimated thickness of the hair as well? The another question is a unit of the length that is being chosen such that the speed of the light in the vacuum here and is unity, and what is the different distance between the sun and the earth in terms of the new unit if the light takes 8 minutes and 20 seconds to cover the distance here. Now the question is, which of the following is the most precise device for measuring the length? The first is the vernier calipers that we talk about it. About the screw gauges that pitch 1 mm and 100 divisions in the circular scale, and an optical instrument that can measure the length within the wavelength of light. Another question we have here is that a student measures here in the same way student measures the thickness of a human hair by looking that through a microscope of magnification 100. He makes 20 observations and finds the averages width of the hair, and the field of the view in the microscope is 3.5 mm. What is the estimate of the thickness of the hair? The another is to answer the following. You are given a thread and a meter scale. How will you estimate the diameter of the thread? The another is the screw gauge has a pitch of 1.0 mm and 200 divisions on the circular scale. Do you think that it is possible to increase the accuracy of the screw gauge arbitrarily by increasing the number of the divisions on a circular scale? The another we have here is that the mean diameter of a thin brass rod is to be measured in the vernier calipers. Why is a set of 100 measurements of the diameter expected to yield a more reliable estimate than a set of the 5 measurements only? Another we have here is another question is that the photographer of a house occupies an area of 1.75 centimeters square on a 35 slide. The slide is projected onto the screen, and the area of the house on the screen is 1.55 square. What is the linear magnification of the projector screen arrangement? Another we have here is state the number of the significant figures in the following, that is 0.007 meters square, 2.64 into 10 to the power 24 kg, 0.2370 grams centimeter inverse cube here. Now we talk about further another one with the same. We have 6.320 joule, 6.032 Newton meter inverse square, 0.0006032 meter square. Now we have another one which is we'll discuss about it, that is being the length, breadth and the thickness of a rectangular sheet of a metal are 4.234 meter, 1.005 meter and 2.01 centimeter respectively. Give the area and the volume of the sheet to correct significant figures here. The another we talk about it, that is being the mass of the box measured by a grosser balance is 2.300 kg. The two gold pieces of the mass is 20.15 gram and the 20.17 gram are added to the box. What is A is the total mass of the box. The B, you have to find the difference in the masses of the pieces of two correct significant figures. Now the another question is a physical quantity P is related to a 4 observation A, B, C and D as follows, which is P equals to A cube B square by under root C D. The percentage error of the measurement in A, B, C, D is are 1%, 3%, 4%, 2% respectively. What is the percentage error in the quantity P? The value, or if the value of the P calculated using the above relation turns out to be 3.763, what value should you round off to the result here? The another question we talk about it, that a book with many printing errors containing 4 different formulas for displacing y of particles undergoing a certain periodic motions, which is y equals to a sine 2 pi t by capital T, where y equals to a sine vt, y equals to a by t sine t by a, t equals to y equals to a under root 2 sine 2 pi t by t plus cos 2 pi t by t, where a is the maximum displacement of the particles, b is the speed of the particles, t is the time period of the motion. The rule of the wrong formula on the dimension grounds that you have to figure it out. Now we're gonna end up with, we'll discuss the rest of the questions. We have more than 15 questions that we have to discuss left for this chapters only. We'll discuss that in the next coming class, that is of 17th. In the same way, we're gonna end up with, in terms of chemistry, we had done your part 1 chemistry for class 11, that is we had done your chemistry there. In part 2 we had started, which is started with the unit 8, which is redox reaction. Coming towards your quantitative aptitude, we had started with arithmetical ability, in that we had done your 14 topic and we are in 15 topic, that is your time and work. After completing that, we'll start discussing about the data interpretation as well. Coming towards reasoning, we had completed your verbal reasoning and non-verbal reasoning, which has been important for the competition one. And coming towards your computer-based numerical and statistical technique, we are dealing with the database management system, where we are dealing with your ER diagrams as well. Coming towards your the another way we talk about it. So here in terms of physics part 1, we are dealing many more things that is related to chapter 1, which is we had done your physical world, that is what is physics, scopes and excitements of physics, technology and society, fundamental forces in nature of your physics laws. The another we are dealing with chapter 2, that is units and measurement. This is introduction, the international systems of unit, measurement of length, measurement of mass, measurement of time, accuracy, precisions of instrument and the errors in the instrument, significant figures, dimensions of physical quantities, dimensions formulas in the dimension equation, dimensional analysis and its application. After we had completed this unit, and we'll surely be starting with another one. Unit 3 will discuss in the next class motion in a straight line. Unit 4 is your motion in a plane. Unit 5 is your laws of motion. Unit 6 is work, energy and power. Unit 7 is system and the particles in the rotational motion. Unit 8 is your gravitation. Then we'll discuss the part 2 as well. So here we're gonna end up with. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you.